All right, let's talk about Webster's method. So this method, it is really the same exact process as the Jefferson's method, except this one has you round down. But for the Webster's method, you round normally. What do I mean by round normally? What I mean is here, 8.04 would still be an 8, but 10.86 would actually go to an 11 on the Webster's method. And a 2.82 would go to a 3 on the Webster's method. So as a reminder, proper rounding looks like this. If I had 3.4, that would round down to a 3. But if I had 3.5, that would actually round up to a 4. And if I had 3.6, that would round up to a 4. In other words, if I have a number right here that is less than 5, I am rounding down. If I have 5 or above, I am rounding up. All right, so let's go ahead and let's try this problem. So here we have different population numbers, and we're looking to distribute 50 representatives. So let's go ahead and add this up. 333 plus 472 plus 195, and that gives us 1,000 people. Remember, to get our standard divisor, we're going to do 1,000 divided by 50. And that gives us a nice number of 20. Now, we are hoping that we can actually get the standard quota and it works. In other words, that we don't need a modified quota. We don't have to change that 20 to a 19.9 or a 20 point something. All right, let's go ahead and let's do 333 divided by 20. Okay, that gives me a 16.65. 472 divided by 20. That gives me a 23.6. And then 195 divided by 20. And that gives me a 9.75. So I like to write this below, but let's round properly and see if we get to 50. We're hoping that we do. Well, 16.65 rounded up is 17. 23.6, we're going to round that one up, we get 24. 9.75, we have to round that up as well, and that's going to give us 10. All right, so let's do 17 plus 24 plus 10, and I'm guessing, yep, that's 51. So that's no good. Okay, in other words, we have to change that 20 to a different number, okay, so that we can actually add up to 50, not 51. Well, think about this, right? These numbers are too high. So if we have a number divided by something and we want our numbers to go down, we actually want our denominator to go up because the bigger our denominator is, the smaller our answer is going to be. Now, if you didn't understand that, that's no big deal. You can really just do guess and check here. I'm going to go ahead, I'm going to just try something slightly bigger than 20, maybe 20.1. Okay, so now I'm going to go back and I'm going to do 333 divided by 20.1, 472 divided by 20.1, and 195 divided by 21. And if it doesn't work, we just have to keep guessing again. So dividing by 20.1 here, I get a 16.56. Dividing 472 by 20.1, I get a 23.48. Ooh, that's close. Gonna have to round that one down. All right, and last is that 195 divided by 20.1, and we get a 9.7. Okay, let's see if this works. A 16.56 would round to 17. A 23.48 would actually round down to a 23. And 9.7 would round up to a 10. Adding those up, a 17, 23, and a 10, we do get 50, so we are done. And so this would be the final allocation on the Webster's method. So again, folks, this is the same process what we've learned before, especially like the Jefferson's method, except this time we're rounding properly, meaning this would be a 16.56 would round to a 17. Okay, and so you just have to change your divisor until you get to 3 values that when you round properly, you get the right allocation value right there that matches that. Thanks for watching, everyone. Have a great day.